Today we're going to be talking about pointers. So basically what a pointer is that it's an object that points towards another object's address. Okay? And I guarantee that nobody understands what I'm talking about. So let me put it out this way. Let's talk about a more concrete example and let's take a look at how the memory works over here. Before I dig into that, I'm going to introduce you to the address of operator. So assuming that I have defined an integer type variable called a and I set the value to 10. What happens in the memory is that it gives it a space inside of memory, and for example over here, and I set the value to 10. Okay, it sits in the memory like that, and it has an address called 0x00. Alright? And the address of operator, when I'm printing it, if I just print out, is this ampersand sign. If you put it in front of a variable, what it does is that it prints out the address of whatever this object is. So in this case, I'm printing out the address of the object A. So what I get over here in this print statement is 0x00. Okay? So now we have a way to take out the address of a certain object. So let's dig into pointers. So pointers is an object that points towards the address of the object that it's trying to point towards. So basically what I'm saying is, assume that I have this is the syntax towards defining a pointer, okay? So this pointer, I know the program knows it's a pointer because I have the star sign up here. So the program is saying that I have this pointer type variable, integer pointer type called ptr1, and I set the value to the address of object A over here. Okay, pointers have types. Okay, so if you're an integer type pointer, you cannot point towards a character, and for a character type pointer, you cannot point towards an integer, for example. So I have an integer type pointer that points towards an integer, so it's valid, and then so this is like one of the ways to define that, and what happens inside the memory is that it gives pointer of like ptr1 over here, assuming that it puts it over here, and the value will be what? The address of the object that it's pointing towards. Okay, so it's going to be what? 0, 0 because it's pointing towards object A. So the value of pointer 1 is 0, 0. Okay, assume we have another variable called b, and it sits here in the memory, and the value is 20. Another way I can define a pointer is I can define an integer pointer at first. And I just define it, and I set the value to the address of the object B. So this line is telling that telling the compiler that I have an object that is an integer pointer type called ptr2, and I'm setting a value to the address of object B. Okay, so what happens here in the memory is that it gives another block of memory, name it ptr2, set the value to the address of what object that's pointing to, B, so it's going to be what? 0, 4. Okay, so this is what happens in the memory when we have a pointer pointing towards another object. Okay, so you might be asking, okay, so now I have the address of a certain object. I want to use this pointer or this memory address to access the value over here. So what I'm going to use here is called the dereference operator, and basically it's just a star sign that we saw earlier when we're defining a pointer. So how do I use it is that in this print statement, for example, I just simply put a star ptr1, and what does it do? What it does is that the star sign goes to this pointer 1, and it follows the address that is being contained in this block over here. It follows it over here, and then fetches the value of whatever is in this block of memory. And because it knows it's a pointer type, it's an integer type of pointer. It's a pointer that points towards an integer, so that it knows that it's just gonna trace down this much memory. Okay, so it knows it's pointing towards the value 10. Okay, so it's just basically putting a star sign in front of the pointer. So you might be asking, like, okay, why do I have to do things this complicated? Because I have to go through different layers and just like linking back and forth through like the memory chunks. Actually, pointers do give you a lot of advantages against using the variables directly. Pointers allow you to work with the object indirectly, which is, as you see, I can use this pointer to access this variable over here. And it is very useful because it allows cheaper copy when we're doing passing like a huge chunk of data, a huge chunk of a data structure into a function. Instead of passing the whole data, I can just pass in a pointer towards that function, towards that data structure, and it allows you to just save all the time, memory, and all the expensive cost that is needed to copy a whole big chunk of data structure. And also, when in future topics, we're going to learn about dynamic memory, and we have to use pointers to keep track of our dynamic memory because dynamic memory is basically allocating memory on the heap, and we only work with the stack. So if we want to access data on the heap, we have to access it indirectly, which is why we need to use pointers. And also, pointers are very useful in a lot of data structures. For example, the backbone of arrays are based on pointers, and a lot of other implementations, such as you're going to learn this in 281, like linked lists or like binary trees. You're going to use like pointers a lot to access those data structures. So this is a fairly simple overview of how pointers work. And yes, any questions?